One day, Dr. B and his son Joe were trying to get out of work from Mrs. B, so they went to a hill at 30 degrees and they did a physics experiment where Dr. B threw a ball at 45 degrees to the horizontal at 10 meters per second, and Joe threw a ball at 45 degrees at a velocity of 5 meters per second. So the question is, who threw the ball farther, Dr. B with this, we'll call it the distance S along this red line, or Joe, distance S along this blue line. When I first looked at this problem, I thought, boy, it'd be easy to figure out if I didn't have this incline right here. Well, you can basically change the problem so you don't have an incline by rotating the axis up 30 degrees. And you have to make some changes when you do that. And you have to change your angle because it was at 45 degrees, but because you rotated it 30 degrees, now you're at a 15-degree angle right here. In order to do the velocity vectors, I'm going to go ahead and make another diagram to make it easier. So here's our 10 meters per second hypotenuse, and then to get the initial velocity in the x direction, that's our adjacent. So we know that cosine of 15 degrees is going to be equal to the adjacent, which is VI of x, over the hypotenuse, which is 10 meters per second. And if we multiply both sides by 10 meters per second, we basically get cosine of 15 degrees times 10 meters per second is going to equal the initial velocity x. Likewise, the initial velocity in the y direction, we know that the sine of 15 degrees is going to equal the opposite, which is VI of y over the hypotenuse, which is 10 meters per second, and you solve for VI of y, and you get sine of 15 degrees times 10 meters per second. So the other change that you have to make when it's on incline is to take into account the acceleration, which is minus 9.8 meters per second squared, which is of course g, and you'll have a gravitational acceleration in the y direction and in the x direction now since you're on an incline. So what is this angle right here? You'll have to trust me that the geometry has been worked out, which I won't do in this video, that it's the same as your hill, so it's 30 degrees. So using our sines and cosines, we can say that a of y is going to be the cosine, because again, adjacent over hypotenuse, which is g, is cosine times g, and then the a of y is, or sorry, a of x is going to be sine. You always usually think of cosine as x and sine as y, but it's different here because 30 degrees, this is opposite over hypotenuse, so it's going to be the sine of 30 times the gravitational acceleration. So basically I'll have our variables now. Now we'll just go with our formulas. If we can find the time it takes to go to the top of the projectile arc, that's when the final velocity goes to zero. This whole formula is basically from the acceleration formula, which is delta V over delta T. And if you solve for delta T, you get this formula right here. So again, final velocity at the top of the arc is zero, and we have our initial velocity right here, which is sine of 15 degrees times 10 meters per second, and our acceleration in the y direction is right here. So we're just going to go ahead and plug those in, and meters will cancel because this is divided by, and then seconds will cancel, and you'll have seconds in the denominator, which puts it in the numerator, which gives you an answer of 0.304, because I assume you know how to type this into your calculator. And of course we'll multiply this times 2 because we need the time it takes to get to the whole distance along the incline, which is from here, from here to here and then here to here. So that's 0.608 seconds it takes for the ball to travel from here to here in the x direction. Distance equation in the s direction is the initial velocity in the x direction times t minus 1/2 a t squared, because the acceleration force is going against the direction that the ball is going, so that's why this is a minus. So we basically just plug our equate our numbers in, because we know that the initial velocity in the x direction is right here, and then we already did the acceleration in the x direction, which is right here. So again, plugging this into the this equation into the calculator should give a distance of 4.978 meters, which I know is correct because Khan did the same problem on one of his videos, but he used a different method of using tangents. But again, I think this is right. So let's move on to doing Joe, and it's the same approach where if we have our x and y axis and rotate it now down 30 degrees, then we're going to have an initial angle of not 45, but 45 plus 30 is 75. So we'll have a 75-degree angle, and to calculate the initial velocity in the x direction is right here, and in the y direction is right here. And I'm not going to go through the sines and cosines again, but this is the cosine of 75 degrees times the hypotenuse, which is 5, and 75 sine of 75 times 5 meters per second. So we can use the same acceleration equations we had before, since we're along the same incline. So we'll just change this to blue, but the only thing that would change would be that the uh, acceleration is no longer a minus, it's a plus, because the acceleration is in the same direction as the direction Joe is throwing the ball. So we have our time formula, and again, at the top of the arc, the final velocity goes to 0. So we'll go ahead and bring down our equations into this equation, and this is a of y coming down here, and again, meters divided by meters cancels, seconds, seconds, so we get, and then plug it into your calculator, and you should get 0.5689, and again, that's the amount of time it takes to get to the top of the arc, so we have to multiply by 2 to get the whole distance here, and time of the whole distance, and that time is 1.137 seconds. And then so it's the distance formula is right here. This will be plus because the acceleration is in the same direction as Joe is throwing it. So the VI of x is right here times our time, which we got right here, plus 1/2 the acceleration in the x direction is right here, times our t squared. So second squared will cancel out with second squareds, and so we're left with meters, and then seconds will cancel out with seconds, and we're left with meters. So we get that Joe threw the ball 4.632 meters. Remember that Dr. B threw the ball at 4.978 meters. Joe threw it at 4.632. I'm not sure this is right, so would love to know if anybody got something different. So I get that Dr. B threw the ball further up the hill. This is the initial velocity of 10 meters per second, angle 45 degrees. Thanks for watching.